Now, the good news is Anna is very experienced with panels. She's going to take over from now and do the round robin introduction. So, Anna, all I'm saying, it's your thing. In an hour's time, can we have our stage back?
Thank you, Charles. It's so nice to have Charles talking before us and after us, give him a bit of an hour to breathe in between. And yeah, my name is Anna Rodewald. I'm very happy to have a very interesting bunch of people here today for our panel on circularity. And we already heard a lot about circularity in the last panel. We will also hear more during the day. And the aim for this panel is that we talk about what do we need to close the loop? What do we need to make out of a linear process a circular process? What is a binding piece which is missing to get materials back and to get them processed to be new materials? And I have the honor to have 5 guests here today, which are not all from the textile industry, and that makes it really interesting. We have Dominik. He is a designer, and he's specialized on circular design, not that much on textile, more on consumer goods. So looking into products which we use on a day-to-day basis in our households, but with a focus on circularity. Then we have Andrea. She has founded a startup looking into an IT solution to get materials back. And then we have Carsten. He is also an entrepreneur. He founded a startup with the aim to recycle textiles into textiles. He raised the question if it is possible to make a fleece pulli, a fleece jumper out of a PET bottle. Why is it not possible the other way around? And he partnered up with Jurgita, with LTP, to give them the material, or LTP gave the material for all the first trials Carsten did in his pilot pilot process to find out what are the best solutions, what are the best material combinations to work on. So this is our panel for the next 45 minutes. We have enough time for your questions afterwards, so just keep them in mind. Charles will collect questions at the end. There will be also some in the online chat. And before we go into the questions, I would ask Dominik to tell a bit more on what is your approach to circular design? Why circular design?
So we have a quite big framework for our working. We say we design for constant metamorphosis. And as we love big frameworks, we say, or we work with the understanding that everything is stardust. So everything around us, everything that consists us is made of stardust. And that makes 2 things. It makes you a sense of humble and a sense of megalomania at the same time. So imagine everything in here is made from stardust, and it's astonishing how this magic around us could happen. And of course, that asks also the question, what could we do with this in the future? If we, and that is very crucial, of course, for circular design, if we reconnect to this metamorphosis that is going on out there. So we work strictly with these 2 paradigms, these 2 metabolism, if you will, the bio-circle and the tech circle, and try to think of new solutions, how we can close this loop. And it has been said in the earlier talk, you need to, as a designer, you need to think of at the end, you need to talk to the recycler, you need to talk to all the different parties to make something like this happen. But we try to be kind of the creative synthesis part of this whole challenge.
Thank you. And from my perspective, design gets a complete new or a very additional part in your responsibility. In the past, design was looking into the beginning of a product and into the use phase probably, but not into the end of life. And I'm an engineer, but from a designer's point of, if I look into this, into the discussion with the designers, I think there is so much more what design can influence now. And I often wonder how we can prepare and how we can support designers in the future to get that job done. And but that might be another question. Passing on to Andrea. Andrea, you're also coming from a complete different background, and you started a startup with the idea to bring materials at the end of life back into the material loop, to bring products, to collect products back and identify them in a way that the raw materials are nutrients for the next process. Can you tell us a bit more about it?
Yeah, of course. Basically, I started with a question that I got in a program that I attended some years ago at Ellen MacArthur Foundation, where they posed this question like, start with the question, what happens next? And that really kept me changing my view on how like everything around us is designed, as you just said. But if you keep asking this question, you really fast come to the point where you ask like, okay, when we use products, what happens next? And that's for me, like that really kind of struck me, where I felt like, okay, that's the point where we have the biggest gap. Like what happens next with most products? Like either we don't know, or what we see is that they end up in places where we just don't want to have them. And therefore, that was for me the starting point to look into, okay, how can we enable really closing loops? And for me, taking back products is just like the entry point to this. Everything that happens afterwards needs some kind of point where it comes back, and then you can look into what makes sense. What can we do with the products? Can we extend product life? Can we recover materials? How can we recycle them? And therefore, I kind of started looking into this topic of take back.
And passing on to Carsten. Carsten also coming from a completely different background. And he jumped into the textile industry with the idea to recycle materials. And so how did he end up there?
Well, thank you very much. Yes, I'm coming from a totally different background. I am a businessman, so I studied business administration, which has nothing to do with recyclability or recycling processes. But there was a red line in my life that was or is to keep resources at hand and keeps them in circularity. So I worked for about 25 years in the recycling industry, mainly with metals. And for about 8 years, I'm now looking at plastics. And sorry for that, but textiles in most cases are nothing special. They are plastics in a different form. So we know packaging, we know bottles, and we know textiles. And especially when we look at materials, when we look at PET or polyester, it does not matter whether it is a bottle, a packaging, or a sweatshirt. And the idea was to develop a technology which is able to continuously depolymerize the PET polymer to its constituent monomers. And the monomers are not crude oil, they are basic chemicals, they are commodities which can be traded globally. So we started to look at the existing patents, and the existing patents describe that the depolymerization of PET is pretty easy. And from there, we had to answer the question how to bring it into to bring it into a continuous depolymerization, and therefore we are using a very simple technology, and that is an extruder. Everybody in the plastics industry, in the yarn manufacturing industry knows extruders. So we are using that technology to bring the reaction of the chemical and the PET into a process, and after that it is just filtration and some precipitation, and finally we have got the monomers and we can produce new polyesters. And to show that it is possible to produce a bottle from a sweatshirt, I brought you some samples. This bottle was in its first life a polycotton sweatshirt. The same with these textiles. So when LTP came to us and asked whether we can test whether we can recycle their textiles, we said yes we can, and so we did. And here are one of the results.
That's a good question to Jurgita. Jurgita working for LTP, and you are the partner for this project with long history, with long history and experience in the textile industry, and you also see all this kind of textile waste on a day-to-day basis, and you approached Carsten to help with finding a solution on that.
Hello everyone, and once again I come from a manufacturing company. We are producing sportswear for various sports brands, and as a participant of entire supply chain, we create our waste, which is mainly textile scraps. And more or less, as we're dealing with it every day, we know that in most cases we have nothing to do with it, only to burn. And we would like the industry to be performing better in this way. So using our networks, we try to build a link between the brand, like scientific company like RITTEC is, and us as a manufacturers. And the speciality of this project is that RITTEC is working with textile scraps, which are blends. They are not monocompositions. And so far the textile does not have solutions for the blends. So we hope that starting from a pilot project, it in a shorter or longer term will become more industrial and more like mass accessible.
Yeah, you mentioned the blends, and if we are looking around here, we are at performance days, and most of the textiles which we see here have the focus on technical performance, and technical performance often is possible to reach with either with synthetic materials or with the blends of synthetic materials. So that's a very crucial part. How did you work out with different blends? What was the possibility? We already heard before that polyester is something which is pretty common, but you have done much more research.
Well, what we do is, oops, very loud. What we do is we started with packaging material. And in the packaging industry, we also have multi-layers, so we have mixed materials. And our focus was not on the bottle, because my saying is, recycling a bottle is easy. Everybody in the room can recycle bottles. You just buy an extruder, shred the bottles, put it into the extruder and produce new plastic. But what are we doing with these mixed materials, with mixed packaging? So we started on that, and we identified that in our process, the PET depolymerizes selectively. So when we treat the mixed materials, only the PET depolymerizes. So everything else, it can be PE or PP films from packaging, or it can be elastan or cotton fibers from textiles, or whatever. They stay inert, and inert means they stay solid. And the depolymerized PET is solved with pure water. Once we have the valuables solved in the water, we can filter off all the impurities. So the process is pretty simple. We have the PET monomers, so the valuables from the PET in this solved fraction, and we have the other materials in this solid fraction. And we, in our case, continue to process the solved part, and yet we are discarding the residues. But we know, and we already started our research on looking at the residues, whether we can have valuable parts out of that as well. So looking on the textile industry, mainly the cotton fraction from blended material is a valuable fraction which can go to pulp production, for example. So we might sell it to Renewcell, we just had in the discussion before. Or we have elastan content in there, although we think that the percentage of elastan is too low and the costs are too high to isolate it, but theoretically we can do that as well. And the same is with nylon, or so polyamides. They all stay as a solid material. We can just separate them and send them to their recycling stream, to their recycling route. And that is, I think, one of the main points you just mentioned. What are we doing? Well, we are just selectively depolymerizing the PET, and anything else stays as it is. And then we can see what we can do with that. And that was also done with the material you sent to us. And we had a polyester result, so we had monomers, and we had the residues, which were cotton parts, for example.
Thank you. Identifying the materials, that is something where Andrea comes into the game. Your solution, your IT solution, can help to identify the materials. Can you tell us a bit more about it?
Yeah, of course. We have different building blocks that we try to put together. Like, first of all, of course, like if you look into taking back products, you have to think of the end consumer, because in the end, it's just a very different way of considering a supply chain, because your end customer is becoming your supplier to some extent. So you really have to create a solution that makes it easy and attractive for end customers to give back products. So this is the first building block that we're looking into. And of course, then it makes sense to look into like what are we getting back and what can we do with those products. And therefore, for now, we're targeting, like with our solution, really brands that look into circular cases that can build up after the use phase. And we're trying to create a solution that is really easy to be integrated into existing shop systems. So really, brands can offer a take-back program. Customers can really easily register the product. Of course, there we have some potentials in terms of, if we talk about digital passports and stuff like that, that will be super helpful in the future. Within textiles, I think it's the difficulty is that there is some quite low level of standardization, and there's, like right now in most cases, no individual product tracking in place yet. Still, like for example, one of our pilot partners is setting up this kind of tracking themselves, so we're really trying to bring that into our solution so customers can really put in the individual number, the product is recognized. In the best case, then we already know like what is the product, what's in there, and then we're trying to look into how can we help customers, or our customers, the brands, find the best way to handle the products. May it be like based on the condition, it makes sense to resell the products. Then, for example, we have a kids fashion brand. They really look into keeping their products in cycles. They offer a pre-loved category. So for them, it's really interesting to then track, for example, how many cycles can a product still make, so really extending the product life. And they also want to recover in the end products that are done, let's say, because they really want to recycle the garn that they use, which is quite sustainable already. That's one case, but of course there are other like use cases that could be interesting. For example, another pilot partner has some kind of shoes that are like the different product, like the different parts of the product are already designed in a kind of modular way, so you can really take them apart, like the nylon and the other parts of the shoe, and they really look more into a recycling case. So they really want to take them back in order to get the material back. So we're really trying to build a system that in the first place enables companies to get back the products, and then we're looking into what are the best streams to bring those products in, maybe based on condition, but maybe also based on the product itself.
Having the possibility to have products in this kind of cascade usage, this is something where the designer comes in place in the beginning. How do you take that into consideration if you work with your partners, with your customers on new products?
Yeah, we of course try to design for longevity, and there you have, as a designer, mainly two big like thinking directions. One is the emotional one, and the other one is the technical one. So of course it doesn't help if you have a very long-lasting product, but users get rid of it very, very quickly. So the emotional one is one task you have to say, you need to design a product that is able to kind of establish a relationship to the user and vice versa. That is kind of the emotional part of that, and there it's all about, you know, incorporating the user to kind of fulfill the product, for instance, is one strategy. There's a whole bunch of it. We have a whole library of different strategies, and then when it comes to the maybe more technical thinking, of course we work with a lot of assemblies, meaning that there are lots of kind of pieces puzzled together, and in older days they haven't been really designed to take apart at the end, or to say, okay, we do know parts are faster paced than others, so they just baked it together, and you had this completely crazy assembly of things that you would never get separate again. So there we really think about modularity, of course, as Andrea already mentioned, and then it's also another thinking that is more towards adaptation. So can we create adaptive products that learn and that are able to change and shapeshift with the user? So we designed a seat cover for a train seat that is able to learn. So every generation of this train seat is better than the previous one, meaning that it's a learning system. I love the thinking, for instance, of Spotify. You know, your Spotify account learns with you, and it adds value through that, right? So you would never give it away because it knows so much about you. And the thinking behind that is, can we do that with products as well that are physical? So these are like the two main realms, and we have a library of like, and we, you know, develop it further and further, because there are many strategies as long as you kind of have the right thinking in place, I think.
So how can a car seat learn?
A train seat.
Train seat, yeah.
So we positioned sensors on the fabric, and while you're using it, you know, the sensors collect data, and of course we do know like the math behind ergonomics, for instance, or about, okay, where does it need to be strong, where can it be soft, and you know, kind of collecting this data through the usage, and then it's a knitting process that we are using, as you are all fabric experts, might be interesting, and then with the next bunch of or the next generation, we can incorporate this knowledge and change kind of the knitting pattern to the better.
So it's a similar information what you would get or what you would see if you would get the material back at the end of life. You see where are the damaged areas, where are the areas which are still in good shape.
Exactly, that's one part of it, and the other one is the sensors that of course collect kind of the user data of where is the pressure, where you know, and the different user scenarios, because it's a very modular and very flexible product. There might be also regional differences of usage that we can collect and then incorporate in the production.
So it's a very technical solution.
This is a very technical solution,
yeah,
yes.
Yeah. And what about repair? Is that something which you can design in, the repairability of a product?
Yes, and I think that is one thing there that's, and you mentioned that it's circular economy is not just an additional piece to design, it's kind of reframing your whole work. And sticking to that train seat design we've done, a normal train seat consists of maybe 50 pieces, and most of them are baked together. So you can't take them apart, you can't repair much. And the first thing we've done to do repairability was to drastically kind of decomplexify the whole system to make it easy for people to change. So we reduced these 50 parts to 6, and we reduced kind of this not monomaterial approaches and say, okay, we have 6 parts and they're all monomaterial, and you can, for instance, the seat cover, it's one piece that you can interchange within seconds, whereas the older versions you can't even take it away. So you need very at the origin of the thinking about the product, you need to incorporate this thinking of repairability. How can I get things apart? And I'm super happy to hear that Carsten now found the perfect solution to take not monomaterials out of each other again, because we desperately need that. Because of course, with monomaterial approaches, you do have some limits, right? There are good reasons for these blends. But that's one thing that really helps us to then do this repairability and monomaterial approaches to really go circular with it.
Thank you. And if we think about scalability, Carsten, your process gets more and more interest. And I guess you will soon think about having bigger extruders and bigger plants. How do you see scalability?
Well, scalability is one point you have to reach when you want to make a process economic and profitable. So the technology we identified is easy to scale up, because the scale up of extruders is well known for years. And we already scaled up the process, especially the crucial process of the depolymerization. Currently, we are running a plant which can operate 50 kilograms per hour. That is not much, so we are not profitable. But we already scaled to 750 kilograms per hour, and we think that we are able to scale up to 1,000 kilograms per hour per machine. And we see the optimized size or the capacity of a recycling site at about 20 to 25,000 tons per year. And why so low numbers? Because transporting waste is a waste of money. So you have to keep low value material on very short distances. And that means you start to set up a network of recycling hubs with smaller capacities for about 20, 25, maybe 50,000 tons per year. And then you have the chance to be profitable. And for us, scalability is in the focus, and we think that by the end of next year, beginning of 2024, we will start operation with an industrial site which has a capacity of 5,000 to 7,000 tons, and as it is a modular design, we can easily raise the capacity and bring it up to a profitable size. And we see profitability given at a capacity around 12,000 to 15,000 tons per year, which is pretty low. So yeah, that is, I think, more in numbers.
This would mean there should be one of these plants close to the production of Jurgita.
So I would like to look into scalability from the perspective of compositions, of different fabric compositions. And first pilot project we are making with RITTEC was made based on 4 different compositions. First 2, they were polyester elastane blend. One had more elastane, another had more elastane. And then 2 others, they were polyester, wool, and one of them elastane blend. And from the results, we know that RITTEC could get quite pure material from polyester. And the wool blends, they did not show good performance in terms of how you decompose the different fibers. But as we do sportswear, and we have a track or some data on what compositions are dominant, we think that the most interesting or the most important or the compositions where we could get bigger numbers of scraps could be like polyester elastane blends starting from like 5 to 30% of elastane, and then of course polyamide and elastane blends. But I'm not sure what status we have with like decomposing polyamide and elastane.
Well, the status is that the polyamide stays as it is. So we can have it as a solid material, we can recycle it and bring it to a different recycling solution. Coming back to the animal fibers, yes, we have realized in the projects we did the first time that we had wool in the process, that the animal fibers, they break in amino acids, and these amino acids, they are, well, impurities in our process. So for the time being, we said we will not accept any animal fibers. But as we know, looking at post-consumer collected materials, we never can be sure that there are no animal fibers inside. So we are now working on a solution to clean our solvent, where we have the valuables from the PET, from the polyester, and to clean, to reduce the impurities from animal fibers so that we can deal with animal fibers as well. We have an idea, but yet we have not realized it.
Coming back to the example with the polyamide and the elastan. So the polyamide will stay the same and the elastan will go into solution?
No, the elastan will also stay as solid. And why is it that case? Because the process temperature in our technology is on maximum 160 degrees. And only the reaction time in the extrusion process is less than 1 minute. So within this minute, the polyamides and the elastin, they possibly shrink or something like that, but they will not dissolve. So they stay as a solid, and that is the positive impact we have, especially when it comes to textile blends, and gives us the opportunity to, well, yes, recycle different setups, different mixtures, whatever.
And what about all the dye stuffs, finishes, silicone patches, whatever what we have on all our functional garments here?
Well, as mentioned, we have a filtration and cleaning up process after the depolymerization, and we get so far, besides the animal fibers, everything out of the process. We are using simple filtration technologies for the solids. We are now integrating membrane technology to clean the solution, and we are using adsorption technologies especially for the solved dyes and other materials, impurities we have in the process. And after the adsorption, we have a very clear, transparent fluid, so it's like water, where we have all the valuables inside. We have the terephthalic acid and the monoethylene glycol solved in that water, and then we add sulfuric acid for the precipitation of the terephthalic acid, and then, well, it's just chemical processes, established chemical processes.
It's a lot of chemical, techy stuff. But one last question on that. What if we have polyester which is based on natural resources like PLA, like biosynthetics? Is that something which can be blended in packaging? There is a lot of blends, and also in textiles it's coming up?
Yes, there's no problem. This is a polyester, and we break it down to its constituents, and we don't care whether the monomers are, or the polymers, PET polymers, are based on bio basis or on fossil basis. The process itself, the recycling process itself, is stable on that. So we have monomers based from bio basis.
So this would mean that we have new possibilities in our industry with the chemical recycling process to widen the limits which we had in the past.
Yes, and the idea is to make especially the polyester world circular, and to close that loop, and to break, or not to break, so to bring the recycling world and the production world together. And we see us, as well as all the technologies we heard in the discussion round before, as the link between the first value chain and the second value chain. And the question we often get, how often can we recycle those monomers? We can do it infinitely. That means we can redo it again and again and again. And in the end, it gives us the opportunity to get away from fossil resources, to base especially our polyester world, on secondary resources. That is the idea behind it, not more.
And identifying, coming back to Andrea, is that something, if you listen to Carsten's explanation, which brings also your business forward, where you can help better to bridge this link between the linear process and the circular process?
Definitely. I think that's a really good news because in the end, when I'm looking at like what makes take back and of course also keeping products in the loop scalable, I do see three main drivers. First of all, we need to change the perception of customers in terms of to really make it as normal as if I buy a product, it's also normal to give it back. So really that's the kind of the change in consumer patterns that we need. The second part is really we need really good automated and stable processes for take back and bringing products in different channels, let's say, for reuse or for recycling. And of course the third part is really we need good and reliable and working solutions of what we can do with products in the end. And therefore, of course, this is a super important part that we need at scale and where we really need to look into how can we create the optimal channels of like what product should flow into which kind of recovery option. I think that's the interesting question where we really need to build good systems because in the end it is really about, I think it's becoming more and more interesting for brands also to participate in this topic of offering like really a full cycle to customers and also just in terms of transparency and sustainability. I think it's a huge topic, but still like even if brands offer individual take-back programs, what happens behind the scenes should definitely be brought together in terms of that we really need broad streams where those products are going. In the best case, maybe into your solution, into different solutions depending on what the materials are, what the product categories are. And I think that's really the infrastructure that we need to create to make sure that every product ends up in the best place possible.
And this kind of infrastructure is not limited to the textile industry, so we need to interact between different industries, as also in architecture, in automotive. We have so many textiles and also other synthetic components which can end up as well in the same kind of process.
Yeah, exactly.
Are you also in contact with this kind of other industries?
Yeah, we started looking into, I think for this whole topic of take back, of course there are other product categories who are super interesting. Of course the whole electronic space is interesting. Of course within the textiles all the functional textiles are interesting. The automotive industry in general is looking into how to recover their own resources in terms of old cars, because that's really becoming a crucial question in terms of supply chains. So for them, it's really a topic of recovering materials and bringing them back into the cycle. So I think in general, that's a part of thinking within circularity is really thinking across borders of individual industries and really thinking more into where should the value go and where can we bundle resources and processes?
Yeah, the value of the resources, that is a crucial question. Everybody who's producing raw materials, producing products today has difficulties to calculate because we don't know what the raw material price in the future will be. And there it goes back to Dominik, you're working a lot with brands. Do they consider this kind of input stream for existing raw materials to get the raw materials back from the consumers to have the raw materials for the next product generation? Is that something brands are already thinking about?
I think they're just starting because of the crisis we are having, because we always used to kind of come up with this proposal and this reason to say, hey, you need your sourcing chains that need to be kind of you need to know that you get the things, but they didn't really listen, and now they do listen, of course, but because there is a scarcity and they are afraid that they won't get their resources to produce their products.
So that means that you also discuss this with your partners, and they start to they start to build up the networks, or how does that work out?
Well, this is not really a part of our work then to do this whole sourcing networking thing, but I think they are much more open to the topic of circular design as such, because they know that their resources are a crucial point for them.
So what would they need to step deeper into it?
Sorry?
What would they need to step deeper into the thinking, how to get raw materials back? Knowledge? Definitely knowledge and lots of partnering and lots of, I mean, I think that's the underlying truth here anyway. Circular design, circular production is a team sport. And of course they need new alliances, new knowledge. Sure.
Maybe if I can add to that, because I'm also having a lot of conversations on these topics, like we want to become more circular, where should we start? Maybe that's the first question. I think a lot of brands who are interested and who might have the intention to do something really are struggling to find the right starting points, like what to do and how to do it. And the second part is definitely also, like, if, for example, if you think about, like, it's not that far away saying, okay, should we take back products? Like, it's an option, but then if you start looking into it, it really fast becomes quite complex in terms of, does it make sense? How to do it? There are no processes in place. You don't have the partners. Like, there are so many questions who are coming up there, and I really believe that's also, for example, one reason why I decided to leave. Like, I've before been in consulting, trying to help companies find solutions in the innovation and sustainability space. And I really saw like there's a need for solutions, really coming with something that you can build on, where you can say, hey, try this, and you can learn from it. You can adapt it for yourself, but you can start somewhere. And I really believe we need more solutions, because there are so many open questions, and it always helps if you really focus on one area. Like, for example, we are trying to focus on this take back and building up the ecosystem to really enable this circular cases. And I think there are a lot of other areas where exactly this approach is needed, where we get a good insight on how to do it, but then open up in terms of that we can really aggregate the insights and help more and more companies realize their own solutions, so adapt it to their needs. I think that's an important part.
Maybe I can also add on that, especially when it comes to circularity and resources and brands and their suppliers. And as already said, communication along the value chain, along the supply chain, is much important. And first brands are now starting to realize that, and especially those in the medium-sized companies. So we are cooperating, for example, with besides LTP, with Schöffel, who brought the loop pens on the market, I think beginning of this year, for the retailers, and now next year for the customers, for the private customers. And they came to us and asked, how shall we design a piece of trousers so that you can recycle it? So we more or less gave the consultancy for the designers. And I think it is the same with you, that as a supplier for the sports industry, you are communicating with your brands, you're communicating with your suppliers and the designers. So we all have to sit together, and now we are coming as a recycler into the game and make it circular.
So in general, we have to discuss this topic from approach of value chain, because each participant of supply chain creates waste, and all waste is in a way connected. The decision by one part of supply chain impacts the result on other participants. But I also wanted to replicate to the circular design concept, because I heard about like repairability or making products more modular or adaptable. But these are completely different approaches, and in a way they only have a conflict from the very beginning, because repairable product means very simple product. Adaptable and modular product already means something which is much more complicated and more difficult to repair. It means that when we talk about sustainability, we are always in front of very complex dilemmas. And it's very personal how which way we choose. It's not easy.
Yeah, it's a team sport. It's not easy, but together we can make it. One last question, I guess, to all of you. Where would you like us to be in 5 years? If we are sitting here in 5 years, I guess we will still be at Performances. Where would you like us to be in terms of circularity?
So, as we are direct in the supply chain, and we know what is the reality, I would definitely not say that after 5 years we will start to collect all the garments from all over the world and we'll start to recycle. For us, the first priority, which I think that industry can solve quickly with the help of the companies like RITTEC, that we collect the scraps from the fabric mills and manufacturers. It is much easier because we do not need the assembly of the products, and also the location of this waste is much more concentrated. It's not spread all over the world. And it's much easier to find the solutions, to build the infrastructures and so on. So for us, as for manufacturers, first priority is possibility to collect the scraps and to provide to the companies like RITTEC for recycling and making our industry much more circular.
Thanks.
Well, where we want to be in 5 years, when I go through these halls and see all the circularity and sustainability advertisements, and I see recycled polyester, my big wish is that in 5 years, no transparent beverage bottle is used to produce recycled polyester for textiles, that recycled polyester from RITTEC's Rodewald PET technology is used, or from others. I don't want to go for that, but that we have closed the circle for polyesters and we do not have to go back to recycled polyester from food industry.
Yeah, I would say in general in 5 years I really hope that we're not at all having this conversation of if a circular economy is needed. So I really hope that we've all come to the understanding that this is the way to go and we need it. And hopefully we've already done some important steps in terms of building the infrastructure and networks that we need in order to really close circles, especially looking across the company and the industry borders.
Thanks.
I think, well, 5 year times, I mean, my wish would be that the word waste is kind of, taken out of our vocabulary. But maybe a bit more realistic, I think the awareness that, yes, it's hard, yes, it's complicated, but it's super fascinating and it's a huge chance for us to rethink.
Cool last word. No, that was the last one.
I would like to complement those the platforms which are helping to track the products and to resell. Because when we talk about finished product and end use of a product, so far the only way to be more sustainable and more circular is to make product more durable and to use it longer time. So it's very good that we have solutions which are helping to do this.
To keep the product as long as possible to be a product. Thanks a lot. We have a few minutes left and we have charts with some questions.
Can I just come back to the last thing you said about waste? That is so important. Nature never has waste, and I think we need to learn that. I've got one online question, but can we first show our appreciation for the guys up here on stage? So I'm obviously going to take questions. If anyone wants a question, they're going to try and answer it quickly. We've got one online. Thank you, Anna. Inspired by seeing a bottle made from sweatshirts, what does the panel think about the challenges or opportunities of closed loop versus open loop, upcycling or downcycling? Would you like to make comment, short and sweet? And if anyone in the audience wants to have a question, we'll get straight onto it. So it's upcycling, downcycle.
Is it to me? Okay. I'm not talking about upcycling and downcycling. I'm talking about recycling. And recycling means we have a material which goes back to what it was and can be the same product as it has been before. So textile to textile, beverage bottle to beverage bottle, packaging to packaging, whatever. And if we close it, when we close the recycling question or answer the recycling question, everything is done.
Brilliant. You're doing it at a higher level than I understand, which is great. Are there any questions from the audience? Yes. You've got people who want to pick your brain further.
Thank you. I'm really fascinated by the mixed composition recycling because that's super exciting. And I just wonder if you have any opinions about the slowdown of fashion, especially there's always this topic of fast fashion. Is the improvement in technology fixes, in increasing technologies for recycling, then hindering any efforts to slow down fast fashion and the consumption of goods?
Well, yes, that is a philosophical question. We are aware that offering a recycling opportunity, we possibly keep things as they are. So we're offering a solution for the fast fashion industry. We are offering a solution for the multi-layered packaging industry. Yes, you can see that critical. But I think independently from the recycling solution or fostering a non-wanted industry, we need, in any case, either fast or slow fashion, a solution for recycling synthetic fibers. And I want to look on this from that point of view. So having a solution for recycling polyester fibers is independent whether it comes from fast or slow fashion. We need it in any case. So resources are there only once, and we have to use them as long as possible.
If I can add to that, of course, and that is very much our intention. I mean, recycling is not the gold standard of circular economy, right? It's kind of the ultima ratio, I'd say, but we need it. And I think if we have it, it's brilliant to have it on the kind of chemistry level, as Carsten is proposing, because that's where it can really work. But I think we need both. And first, of course, we also need to focus on, changing the concept behind consumption, about fast fashion, behind our connection to nature. Also, I think talking about performance fabrics, I think it's all one out of this paradigm of man versus wild, right? And that is kind of the underlying truth that we need to connect differently to nature. And if we connect differently to nature, I think you recognize that it's all about chemistry. And recycling as such is a very natural thinking, I think. And if we have the right solutions there, you can do both, and both is absolutely right.
Are there any other questions? In which case, can we make two thank you? Not only the panel, but Anna, you've created such a marvelous mix of, there's not a simple solution is what I'm taking away. You're all facing in the same direction, but the detail from each of you has been fascinating. So Anna, thank you for the team, but can we show our appreciation again to the panel?
Thank you to the audience. Thanks for your questions. Thanks for listening. And our panelists are here for a few minutes. So if you have individual questions, just take the chance to meet them in person. Thanks a lot.